Testing 1, 2, 3. Can anyone put their hand up if they can hear me? Okay, cool. So how this is going to work is I'm going to try going through an intro to Unity. We're going to have one lesson first for 50 minutes, and it's going to be basically a basics Unity lesson. And then what's going to happen is we're going to have like a 30-minute break where you guys will have like a Kahoot and some like break time. Then we're going to a more advanced thing where we'll do some animations. Now, one thing though is I'll be going through it like basic walkthrough style. If you guys have any questions, just leave it in the chat. Yeah, and I'll be able to look at your chat as well. Is that clear? And then I guess I'll give 2 minutes for everyone else to join in, and then I'll start. And you guys can put down your hands now. It's good. Just I want to test on something. Can someone try sending a message in the chat? Okay, thanks. Got it. Cool. Okay, I think we should be good to go then. So, yeah. So this, we'll start off by creating a new project. I already created one, but I'll show you guys how to do it. You guys should have Unity or Unity Hub installed. And when you open up Unity Hub, it might look different, but you should be able to click new. We're going to create a new project here. You can name the project like I named it this project 7WC Game Dev. So this is the 7-week challenge game dev portion, right? It already exists because this project, obviously. And we're going to be using Unity3D, and you should be able to click create. And then once you create it, you have a project, and that opens up much like this one. And then from here, we can start talking about it. Can I just get a like fingers up if everyone got at least the thing open? A new Unity project open? Thumbs up. Okay, I'll start talking about it and then okay. I'll start talking about it and then hopefully it'll load in the meantime, and then for verifications it should be good. Yep, got it. Okay, so for those new at Unity, there are different portions of the Unity editor, and we're going to talk about some particular ones. So here you can see that this section is called the hierarchy. This section is called scene. Then you have the game window as well, the inspector, the project window, and the console window. So simply said, the project is where our assets will be. So right now we only have our sample scene, right? Which is right here. And this is our hierarchy. That's why it says sample scene here. And basically all of our models, images, animations, whatever we need in our hierarchy or like assets that we call it, we'll be able to search up in our project. Our project is basically like your file manager system in like Windows. So all the files and things that your project will be referencing will be accessed in this project window. Then we move on to the hierarchy. Actually, we'll move on to the scene first. So the scene is basically your 3D world. Because we're working in 3D, there's three axes, right? X, Y, Z, as you can see at the top right here. And what happens is this is basically the entire game world. And the difference between the scene window and the game window is the game is what the player will see. Right now, in our scene, we have a main camera, right? And this main camera is simply what the player sees. So when I click play, what a user will see when they play the game. So right now, because the camera is only facing in this direction, they'll only see this, right? And simply like if I were to turn off the camera, you can see now because we have no active cameras in the scene, there's no displays and hence nothing is nothing is shown. Next, we also have the hierarchy. So basically this is our objects within the scene. Right now there are two things in the scene. There's a camera which allows people to see out in the scene. This is default. And the next thing is the direction. So the directional light is just gives lighting as every like 3D room. If you think about it, there must be light in it, right? So like if I turn it off or on, you'll see more in the game that basically what happens is when you like when I put an object in, you'll see the lighting on the object. We have no objects here, so there's no lighting anywhere. And then so right now we have these two objects in the scene. And this is we talked about the scene and the game windows. Lastly, there's the inspector, which if you can see when I click on an object, it gives me the properties of that object. It gives me a transform property and a light property for this directional light. Every object in this hierarchy in Unity will have the transform component. What the transform component does is it gives something in 3D a position, and a rotation, and a scale. A scale won't matter for empty objects, but basically just think about it like in 3D, we have three dimensions, right? X, Y, Z. That's why the positioning, we have a position for that and an orientation. And then that's the basics. And then there's also console. So I've heard you guys did Python basics. And in Python basics, they basically have something like you can print stuff out, right? So basically all of the prints will happen here. You can print out like items in runtime and it'll print here. Also, your warnings and errors will appear here. So if there's anything wrong, you can go back here and see what's happening. So those are the basic components of the Unity like developer system. And I guess now we'll start with actually making something. I think the best way to learn in Unity is just to try making something and see if you get it. I just want to make sure that before I start, everyone's a bit okay now. They have the Unity editor open at least. Thumbs up if you have the Unity editor open. Okay. Cool. So what I'm going to do is we're going to start off by creating something in this world. And we're going to start by right-clicking in our hierarchy because the hierarchy basically holds all the objects in the scene. So if we want to create an object in our scene or in our project or like have something in our game, we need to put it into our hierarchy. So what we can do is we're going to right-click and then you can scroll down to 3D object and you should be able to click cube. And then here you get a cube and I just click enter. And now you have a cube. You can double click on it to zoom in on it in 3D if you lose anything. Like if I double clicked on directional light, it zooms on that. Double click on camera, goes there. Double click on cube, you can find it, right? And here, now we have a cube, right? Now, before we start, we want to try finding like objects. We want to understand the controls in our 3D scene, right? So if you look at the top left here, there's a hand tour, a move tour, a rotate tour, a scale tour, and a rect tour. These two, like, they're useful, but we won't use them at least for this tutorial. For hand, what you'll see is that the hand tour, you can basically just pan, right? You can pan in the 2D platform and go left to right? Move tool allows you to move an object, so you can move it in any of the axes, right? And if you see like I can hover on a box and I can move it in a 2-dimensional plane as well, right? And that's how you can move objects. I'm just going to put it back to the origin again, because yeah. Anyways, then you have the rotate tool, and basically what this allows you to do is rotate. And you can see that in any of these motions that I'm doing. What happens is you can see that the transform is changing, right? 1 second. Sorry about that. So you can see that the transform is changing, right? As I change using the rotate tool, as I rotate, the angles are changing in the rotation. And if I were to use the position tool again, you see that it changes the transform. And that's what's useful about the transform. Whatever data is in the transform will make the position or orientation in the real world. Okay. Also, just these tools are useful and you can use them. But the way I like to do it is you can zoom in and zoom out using your scroll wheel in Unity. So if you have a mouse, using the scroll wheel will allow you to zoom in and out. Then if you right click and drag, you can basically like pan in all directions, right? And then finally, like you can just click on objects and use them like how you would, right? So now that's how you get a cube in Unity. Now let's move on to making this cube move, and hopefully getting some scripts onto it and making it look better, right? So firstly, what we'll do is we're going to create one more 3D object. We're going to call this a plane, okay? What I'm going to do is I'm going to make this also at the origin. Unity has a weird thing where like it doesn't it puts it at like what you're focused on. I'm just going to move it down -1 so it's beneath the cube, right? And what I'm going to call this is going to be our ground. However, like if you look at the scene, right, it's very like monotonic. Doesn't look good, right? So what we're going to do is we're going to try adding some color, making it more flashy. And the way we're going to do that is we're going to make a new folder in Unity. You should think of this as a file manager, right? So you always want to be clean so that if you want to give your project to other people, they'll be able to understand it. So I added a new asset card materials. I just right clicked and create new folder. And then I made a new folder called materials. And a material is what we can put on objects to make it look different. It gives it texture and gives it different colors, right? So the way we can create a material is you can right click again, go to create, and then go to material. And you can create a material. I'm going to call this red. And then what happens is we can just make like a red type color, like maybe like, I don't know, whatever you like. I'm just going to do something like this. And I can drag it onto this cube. And now you can see that this cube now is, instead of being red, is now brighter colors, right? And we can do that one more time, and we can create another material. And we can call this green. And now if I were to click play, we'll see that the play button automatically puts you into the game scene. And now that you're in the game scene, this is what the player will see. Yeah, you can create gradients. Like all of these, you can create gradients. You can even add metallics and textures. Usually though, what happens is I don't use like for me, when I create stuff, I usually don't use Unity. What happens is you can even put images onto here. So you can, what happens is usually what happens, you have a model, right? And then you have a texture on the model, and that is a 2D image that gets wrapped around an object, right? So technically you can always create gradients. I don't know if there's a way from Unity itself, but what you can do is you can take a gradient picture and you can wrap it onto this object, if that answers your question. And no, it doesn't have to always be one solid color. Yeah, so you can change it to images. I don't have an image right now, but I'll show you later. In the second part, we'll have a texture pack, and I'll show you how those textures work. Okay. Now that we have this, what we want to do is when we create play, right? We see that our cube is floating, right? But we don't want our cube to ever be floating because in our game, like in the real world, there's gravity, right? So we want to go back and do the work Isaac Newton did, but in a much faster time. So we see that there's first a box collider on this, right? And a box collider, any colliders that are not trigger colliders usually can have some physics attached to them. So in order to add physics into this box, we're going to add a rigid body. A rigid body gives allows it to be put into the physics engine by giving it mass and also allowing us to say, okay, this box, I want it to use gravity, right? So hence, we got a box with gravity. Now, I'm just going to move this up so you guys can see. If I click play, boom. We've done what Isaac Newton took 100 years to do in much faster time. Great job, guys. Anyways, so yeah, as I said, this rigid body allows us to give gravity to objects, and it allows it to basically collide. So we have a box collider here, and I don't know if you guys noticed, but our plane also has a mesh collider on it, right? And the two colliders will collide, and that's what gives us gravity. Like if I were to turn off the mesh collider, then you'll see that it went right through, right? So hence you need colliders on both objects to start using rigid bodies. Now that we have our gravity working, we're going to actually start trying to code. By the way, guys, am I going too fast? Is everyone good here? Yeah, the rigid body basically makes, okay, cool. And the rigid body basically adds a physics engine onto the object that says, okay, I want this to far, I want it to have this mass, this angular jag, and I want it to be like this, basically. And this is the physics, like this does the physics for you. And we're going to be looking more at rigid bodies when we look at the collisions later too. Okay. Now what we're going to start trying to do is we're going to start trying to get input and making this box actually move. First thing I want to point an attention at is the axis systems. So for those of you who haven't looked at the 3 dimensions yet, there's 3 axis systems, X, Y, and Z, right? And from the way that our camera is facing, so we should always look at the scene with respect to the camera, right? So from the way our camera is facing, we see that our Z-axis goes across the screen like this way, and the X-axis goes down, right? If we were to look at it from a bird's eye view. And the reason I'm saying this now is we're going to try to make this box move using like WASD. Well, where do you find rigid body? So for a rigid body, all you have to do is click add component, and you should just be able to type rigid body and it'll come up. Remember, we're in 3D, so use the rigid body, not the rigid body 2D. Are you good, Alexander? Alex Pinde? I don't know. Are you good? Okay, anyways. So the way I made it fall straight to the plane was it should not automatically fall straight to the plane. What happens is it should, if you have a mesh collider, when I turned it off, then it fell through the plane. As long as both objects have colliders on it and one has a rigid body, it should be able to collide properly. Anyways, continuing on. As I said before, we have a X going in the right direction and Z going in the forward direction, right? And what we should be able to do, if you yo guys, by the way, if you guys are getting any specific errors on like runtime, and it's not like specific, then guys just DM me later and I'll try to help you because yeah, we're trying to get through this tutorial. And Dorothy, for you, the non-convex mesh collider, I think did you add the rigid body to the cube? Because there shouldn't be a mesh collider on the cube. There should just be a boss collider. If that doesn't work though, and you guys have like specific questions that are actually not working, try DMing after, and I'll try helping each one of you. Anyways, now that we're back on this, we have our box, right? And we want to move it forward, backwards, and right. So what we're going to need to do is we're going to need to add a script. And what we're going to need to do then is we're going to like how you guys code, right? Because Unity is a developing platform, so you need to be able to code. So I'm going to teach you guys how to code now, big part. First, what I did is obviously add another folder. We want everything to look nice. I'm going to create another folder called part 1 or part A because we're going to have 2 parts to this lesson. And I'm going to be calling this, and we're going to be calling this movement. And then when you open this, right, you should have the Visual Studio pop up. Might take some time. Anyways, so this is a blank file that I called movement, and this is how a script, the Unity scripting language starts. Okay, anyways, we start off with the function called start, right? It starts with 2 functions. One is called start and one is called update. Okay, what start does is it runs once before the first frame, and then the update runs once on every frame update, right? So you know how you have FPS 60 frames per second? Every frame on a computer, doesn't matter how much frames the computer is putting out, on every frame update, this will be called, okay? So what we're going to do now is we're going to start trying to code. And what I mean by that is we're going to have an int, and what this is going to be doing is it's going to be telling us how to move. So when you move, right, you are going to be using WASD keys, and for that we have a left move and a right move, right? And if we look back at our Unity screen again, we see that this box, it has a change X and a change Z. We're only going to be looking at like basically it's only going to be moving on this plane, right? On this plane, no, not that plane. On this plane. It's only going to be able to move on this plane, right? It can't move up and down. It can only move like on the plane, right? So what we're going to do is we're going to have a change X and a change Y, a change X, change Z, right? Because that's going to be moving in the X direction and the Z direction. And this is going to represent each axis, right? Then what we're going to do is we're going to have a public float. So we're going to have a speed variable. And here what's going to happen is we're going to first start every update. And we're going to start with change X equals 0, change Y equals 0. What this means is if nothing of WASD is being clicked, we do not want to move at all, right? And then the next thing I need to teach you guys in scripting is how to actually get input from your keyboard. So in Unity, there's something called input.getKey, right? This is a function, and what it does is it checks if this key is down. It doesn't matter if you clicked it or if you released it. As long as this button is pressed down, this would be true, okay? And what we want to do now is we want to tell it what key we want to do. So in Unity, it's very simple, much like Python. Each key has a key code, and then all you have to do is type what letter we're going to be using right here. So we have W, right? So that means key code W is 119. Each key code is simply marked to a number, right? And then that number is then used to like, that number is what Unity uses to check the individual keys. But realistically, we can just do key code .w, and this will just check if the W key is down. And what happens when the W key is down? We want to move forward, right? WASD keys. I'm sure you guys have used that before in some way or shape or form. And if the W key is down, we want to move in the Z direction, right? Because from our camera's point of view, we're looking at it from here, right? And what this means is that we want to look at the cube moving in this direction. And this direction means the positive Z direction. So therefore, what we need to do is we make change Z equal to 1 here. And then the next thing we'll do is we'll check if the key code of S is right. What do you guys think the key code of S is going to be? Just type in the chat. Like, how would I get, using the symmetry from line 20, how would I check that S is being held down? Yep, I changed Z by -1. Yep, because we're going backwards in that direction. But for S, what do you think I type here, and specifically in this spot, to try getting the S key? Yep. It's key code.s here. Much like Python, this is very simple in syntax for key codes at least. And what this says is that this is equal to -1. Also, what I'm going to do first, I should have done this at the very beginning, is there's Unity documentation, okay? And you can see that this documentation basically has all the Unity codes you need, right? And if I want to look at input, I look at input, and I can get key code from here, I think. Or you can just search up key code. Okay, the way I just search up is just do key code Unity documentation. So basically, these are all the key codes that you can use. And if you just do key code dot this will give you the keys. Okay, so you have key code dot none, key code dot backspace, and all of these. And these are all your keys on the keyboard. And using this, you can check exactly what syntax you need. For example, for left bracket or left bracket or enters, they're all here, right? Okay, going back, now I'm just going to quickly finish the rest. So in order just to make sure, we got key code dot A, right? Now, what direction will A go in? A, remember, we're looking at it from this point of view. So we did up and down, right? So that was this Z backwards and Z forwards, right? So we did these two. Now A is going left, right? So we want to work with the x-axis now. And what this tells us is that for the x-axis, we have A going left, right? That means that it should be change x equals -1. Oops. And next, what you do is you have to check for the last key, which is key code dot D, right? Because we're using WASD keys. And from here, you get change x equals 1. And now we want to actually see this in motion. So what we're going to do is we're going to say this dot transform. So what this does is it gets the object that this script will be attached on, and transform gets the transformation component of this object, right? And if you look here, we saw that the lesson plan should already be linked. I'll send it in the chat though. So this dot transform dot position will get us the position component, and these position is a vector 3 component. And what that means is there's 3 parameters, right? X, Y, Z. So a vector 3 is simply like, I just do an example. Vector 3 vect equals new vector 3. So a vector 3 has 3 components. And if I hover over this, it doesn't show you. So see, it's a float X, float Y, right? And it sets Z to 0. So what this means is that if we put this as change underscore X 0, because we know that our Y is going to be 0, change underscore Z, we can change this transform into this dot transform dot position, and we can add our change vector. And I just call this change, actually. So now I'll show you the beauty of this quickly, and then we can try going through the code if anyone doesn't understand. What we can do now is Unity is a scripting platform, right? So when I click play, I can add the script onto this by simply dragging. I just add the component. I'm going to add movement. So now the movement script is added, right? Now, oh, see, here we got an error. Change Y does not exist. So I must have put change Y somewhere. Where's change Y? If you double click on the arrow, it will take you to it. Oh, I see. So should we change underscore Z equals 0? And now when this finishes loading, you click play. And you will see that if I use the WASD keys, oh, see how it just shot off? What we want to do now is we want to add a speed parameter. So that was what my public float speed was before. And what we can do now is we can take speed times this vector. What this would do is it'll take whatever we're trying to change, like the 1, 1 vector, whatever we're trying to change by, and it'll multiply it by a speed parameter. And what this would do is now if I go back to our cube and our movement script, see how our speed is 0? I can add this to 0.05, let's say. And now if I click play, it goes, if I do 0.005, I thought I actually should do something different. Let's do it here. So the reason I'm doing it here is because I don't want to make my change different. Basically, because vector 3, I want to actually add it to the position. And this will just, I don't think it matters, but. So now, because it's 0.05, it's really, really slow, right? But so if we go and make this 1, see how it moves a bit slower now? And now if I were to make this 0.01, it'll move a bit faster. You guys see it? And I can actually change this during runtime in the editor. So then if I make this like, let's say 50, and I go back to my game, it's gone because it went so fast, right? And obviously I'll play this again so you guys can see it. But you guys get the idea, right? How by changing the smart speed parameter now, I'm able to adjust the speed. So I'll put it back to 0.05. And you guys can see, right? Now we got a moving cube. Okay, now let's go back and ask some questions. Yes, I'm going to go into that right now, actually, right after this. I'm going to show you how we can parent the camera into the cube and make the camera move with the cube. And I'm also going to show you a bit of rotation as well. So realistically, this is not a 3D game yet, right? We're just looking at it from a 2D perspective, basically. And we're just moving a cube left and right. So what we want to do is we want to move with the cube, right? So what this means we're going to have to do is if the cube, let's say, was facing a different direction, right? Let's go back to the beginning. And let's put the speed back to normal. And let's make our cube oriented different, right? So now what should happen is that if our cube is oriented different, right, then the cube should be going in the direction that it's oriented in, right? But you see that the way we're doing it right now, we'll make it so that the cube will only move in the X, Y, Z direction, right? That means if we were to rotate our cube, it won't go in the direction it's facing. You guys get that? The cube, when it's rotated, will not go in a direction it's facing. It's only moving along the X and Z axis. So we're going to have to actually change the code a bit so that we can make the cube go in the direction it's rotating. And while we're at it, we'll also make the cube rotate along with our mouse. So the way we're going to do this is we're going to first we're going to first edit our movement script so that it changes the orientation. And the way we're going to do this is we're going to first make our cursor locked. And the way we do this, we do cursor dot lock state equals cursor lock mode dot lock. And what this will do now is when I click play, see my mouse? My mouse is gone. What this does is it basically locks your mouse onto the screen. And now there's no mouse anywhere, right? So that means when we rotate, there'll be no mouse that's like jittering around. Now, if I want my mouse back, I can escape. And you see my mouse is back, right? Cool. Now, what we're going to do is we're going to try making our thing rotate with our mouse first. The way we do this is we simply change our horizontal rotation. So we first need to get the position of the mouse on the screen. And what we're going to do is we're also going to have a speed for our horizontal rotation speed so that we can like adjust our sensitivity if we need to in the future. Different mouses might have different sensitivity, so it'll be useful. Anyways, so what we're going to do is we're going to do our horizontal rotation is going to be a vector 3. and it's actually going to be a float. A float for our horizontal rotation is going to tell us like what we need to add to our rotation. Because if you look at it, our rotation of this cube is only dependent on one value, and that's going to be the y rotation, right? I'm only going to be rotating along the y-axis. And then what's going to happen here is we're going to have a horizontal rotation, and we're going to start by setting it 0. It's always going to start at 0, and then we're going to add stuff to it. And what we're going to add is we're going to add the speed. So we want to obviously make it be affected by the horizontal speed of rotation. And we're going to multiply that by the x value that it gets. So what happens is you always have an x, even when your cursor is locked, you always have an x position. And we can get the axis of that x position by doing this. This would simply get, so if I were to go back, if you look at this, this movement is going to give me a value on this 2D screen, right? This 2D value is going to basically be this input.getAxis mouse x. And using that, I'll be able to add that to my horizontal rotation. And now from here, what I do is I simply make our actual rotation vector. So you guys, this is a bit of math, but this basically just gets the Euler Angles, and Euler Angles is just, if you think about it, angles in 3D, so it's just a representation of our rotation. And what we're going to do is we want to make sure our Euler Angles are rotated. So we're going to change our rotation such that it becomes a new, so our Euler vectors, because there's 3 sets, it's still in vector 3. And what's going to happen is we're going to make it our x rotation. And what we're going to do, so what this basically says is that this will not change the x position. We'll change the horizontal position to be whatever our horizontal rotation is. And we're going to change our z rotation to be nothing, because our z rotation is never going to change. And simply by doing this, you'll see that we can get results. Let me just make sure that I didn't mess up anywhere. Let's say expected semicolon. So I missed a semicolon somewhere. Oh. So basically what happened there is, if you guys know that we're doing type identification here. So a float, you know what a float, guys, is in Python, right? So we're just identifying this variable to have this type, and then we're continuing on. And we can't, the error happened because you can't make a float like here, and then you can't just make a float again, or it's not going to actually access this float. It's going to make a local variable. Anyways, now if I were to go back to our game, oh, we forgot to set the rotation. So what happens here is we need to make sure that this is always, we're going to actually debug.log. So in Python, you know how you guys have print statements? This is the simple thing that you can debug.log the rotation. And now from here, what happens is it'll tell us the rotation that we need. And we'll be able to see if it's actually changing anything. Oh, yeah, that makes sense. So what you see is that it's always 0, right? That means it's not rotating. The reason is our horizontal speed is set to be h, right? That should be. So what we need to do is we need to make this a non-zero thing. Otherwise, if a speed is 0, no matter how much you move, you're never going to move anywhere, right? No matter what distance we do. So what we're going to do is we're going to set this to 1 and we're going to run again. Okay, so the reason you can multiply by time dot delta time, but you see that I'm not actually. So the reason why we're not multiplying by time dot delta time is because I'm adding to our original rotation and position. That means we don't have to multiply because we're just adding continuously every frame, right? And that's the same thing as multiplying by a time dot delta time. If I was going to set equals, then I need to multiply by time dot delta time, if that makes sense. No problem. So now if you see now, like as I move my mouse right and left, you should see that your box rotates. But now again, we'll see a problem. I'm rotating right and left, right? But if I go straight, it's not like my orientation doesn't change my direction of motion, right? And in real life, your orientation should change your direction of motion, right? I mean, if you're facing backwards, you shouldn't be walking forwards, right? So now we need to make our orientation change, our direction. And the way we do this is actually a bit more math, but what happens is instead of using change X and change Z, we're going to actually start by getting a forward direction first. And the way we do this is we get a vector 3, and we're going to call this vector 3 forward. And we're going to call this transform dot forward dot normalized. And this just normalizes a direction, and the transform dot forward basically gets the object, the cube's object, in the forward position. And that will actually change depending on its local orientation. And what that just basically means is it'll get the forward vector that the cube has no matter like changing with its orientation. And now I'm going to get the right direction. Now this is the part where math comes in. I'm going to use a cross product here. So the cross product basically gets a perpendicular vector. And if I use the forward vector and the upwards vector, I will be able to get the right vector. And now our change, instead before our change X was simply our change X, change Z, right? But now what we're going to do is we're going to actually use our forward and backward things to check. So our forward, because our change X is only 1, 0, or -1, what this tells us is that we want our change to be a forward direction or backwards direction or nothing, right? So this is either going to be forward, negative forward, or 0. And now we're going to add that onto a change Z times right. And we're going to first take this and we're going to see if this works. That's what we're going to do. And the way we're going to do this, we're going to actually check. Yeah, we'll just go from here. So now that we added our change, we'll see if our axes are still right. So you see I can rotate, right? And now I'm actually going in the direction. But there's one problem with this. All right, let me try doing this one more time. Okay. Let me try running this one more time. And you see that we have. So see, the reason is my axes are actually inverted, right? I'm going up, but I'm going left. I'm going down, but I'm going right. I'm going right, but I'm going up. And I'm going left, but I'm going down, right? So what this means is that my change X and change Z, I actually did them in the wrong axis. Remember, we said change Z was actually our forward direction. So yeah, this should be change Z and this should be change X. Coding is about a bunch of trial and error. Trust. Anyways, we can try playing this again and seeing if we need any more changes in our axes. So now our up and down works, right? I can go up and down in this proper direction. The problem is our right and left doesn't work. And the reason is, for you guys who are in more advanced levels of physics and math, if you use the right-hand rule, this is actually not right. This is actually left. So what we need to do in order to make it left, right, is we need to take the negative direction. In 3D, the perpendicular vector to two vectors is always going to be using the right-hand rule, right? And in order to get using the right-hand rule, if we use our forward direction and our upwards direction, we need to take the negative in order to get our correct direction. So what this will do, when we run it now, is you can see that our forward and everything works, right? And you can even see that I can now rotate in any direction, right? Now, finally, there's just one last thing I want to show you, and that's camera. So as one of you said, I forget, but one of you said that we can actually put the camera into the cube and make it so that the camera follows the cube, right? I'm just going to make this 0, 0, 0, 0, 0, right? Make it simple. So now what we'll see, I don't think I saved it. Oh, I see. We're going to make this 0, 0. I'm going to try like this. I'm going to make the orientation. So now you see that when I move, right, my camera follows behind my thing, right, like my cube. And last thing that I want to do in the first lesson actually is show you the different viewpoints. So in every game, 3D game, you can either have a first point viewpoint character, or you can have like a different viewpoint, right, like third person viewpoint. And what we're going to do is we're going to actually make a camera position. I like doing this for most of my projects that I do too, because what happens is I can move this camera position whatever I like. I can take the camera position out, and now here what we'll see is based on this empty object, if I position this empty object wherever I want, let's say 0, 0, 0, right? I can actually reference that empty object. I'm going to make a new script actually. And we're going to create a new C# script and I'm going to call this camera controller. And what happens from our camera controller is that simply we're going to make this camera control allow us to do different viewpoints along with allowing us to rotate up and down. So obviously we need a float for our speed. We're going to have a float for our min and a public float for our max. And we're going to have a public game object called our positioner. So this positioner is going to be my camera position that I have in the hierarchy. And simply what happens is I don't actually need the start skip, so I'm just going to get rid of that. And what we're going to do is we're going to, again, get our camera rotation by just doing input. Now we're going to be using our y-axis. And we're also going to be getting rotation. So this is the original rotation, right? And we're going to get float rotation equals our, we only want to now look at the Euler angles in the x direction. And how we're going to do this, so what I'm trying to do here is I'm trying to be able to rotate my mouse up and down like this. We've done rotation like this, right? Now we want to try moving our camera up and down like this. And our min and max are like our cutoff points. And what we're going to do is we're going to check if our rotation is greater than 180. And if it is, that means that we want our rotation to always be between 0 and 180 when we do math. Because if it's beyond 360, then it's not good. And now what we're going to do is if min is greater than our rotation, that means that our rotation is like in between the ones that we don't want. So if the minimum value is greater than our rotation or the max is less than our rotation, what that means is that the rotation that we have is not between our min and max values. Hence, we need to make our transform.Euler angles equal the original rotation. And what then we need to do is right here, we're going to actually try to rotate it. And finally, what we're going to do is we're going to take our transform.Euler angles and we're going to make a new So what this will do is when we rotate something, sometimes it will give us a Z value, right? But we don't want to have any rotations on Z. So we're just going to zero our rotations there. And finally, what we're going to do is we're going to change our position to match our positioner. Now, this is going to be very useful, this script, because we're going to be able to use this in the second part too. And I'll show you how it works, then I'll go over it quickly, and then I think that's it for our first lesson. So how this is going to work is this script will actually go on our camera. Oh, wait. Okay. So now what we're just going to do is going to add our camera controller onto this script. And what we see is we have a speed. So for our speed here, we're going to make this, let's just do 1 here. And we're going to have like, let's just do like -30, 30. And our positioner is going to be this. Now, if I were to click play, so you see right now, I'm in first person point of view. I can look up and I can look down, right? And I can also move here and I can go forward and backwards. You can't really see it because it's first person, right? So what we can do now is using our camera positioner, actually, we can actually try moving it at different locations. So if you see, I'm now going to move my camera rotation a bit back and elevate it a bit, and you'll be able to see like the beauty with the camera positioner. Like just by changing the camera position value, I'm able to move like the specific direction, right? And I need to actually put this in here. So now what happens is just based on moving my camera positioner, I'm able to change how, like what position my camera is at, right? And the big reason we're using this right now is because in the second part, when we use humanoid animations, it's going to be much more difficult to do if we do everything on our main camera. You guys see like how the position is changing the camera position? So I'm just changing the position of the camera pause, right? And like, let's say I move all of this back. You see that my camera, see my camera is now changed to B, and it still moves with the box, but it doesn't like, I'm able to still rotate and everything, but it basically has a fixed position from the box based on the camera position. Okay, now let's go through the code. So as I said before, the X got the X position, the Y get the Y position, and we multiply by a speed so we can get a rotation speed. You can try changing the speed depending on your mouse, but it's okay. What we're doing here now with the original rotation is this is what our clamper does. So if you look, when we played the game, right, we could move up and down until a certain value, right? We can move up, but we can't move more up than this. And we can move down, but we can't move more down than this, right? And that's what our clamper does. It stores the original rotation. It tries to rotate the camera in that position, and then it checks if the new rotated position is in between the max and min angles. If the max and min angles if it's not in between the max and min angles, it changes our rotation back to the original rotation. And then this just tells us to zero the Z value. And then we change the position so that it follows. Like we change the position to follow our positioning. Does everyone get that? So what we do is we store the original rotation. We try rotating it here. If the rotation does not match our clamp values, then we reset the original rotation to be our rotation because we didn't, if it's not within the clamp values, we're not going to rotate it. And then this just zeros the Z angle because if you look at it, we never want the Z angle to be non-zero. And I'll explain why. If our Z angle is non-zero on the camera, that means that our Z angle is like this. Oh, I'll explain like this. I'll explain this soon. If our Z angle were to be non-zero, that means we start getting a camera that looks like this. You see? This gives you a rocky effect, especially in other applications like VR. This is horrible. Okay? You see, you never want to be rotated in this direction. So that's why we keep that to be zero. Okay. Okay, unload your questions now. Any questions about anything? Guys, I don't think I explained this too simply. Yeah. Okay, so the camera pause, right? What I just did is for objects, we don't need a 3D object, effects, or lights, right? That means we can just create a simple empty. What an empty is just a game object with only a transform. You can simply make any object into a empty object by just having a transform, right? And simply what the camera position does is in the scene, again, no matter where I put the camera position, right? Like let's say I put it back to 0. Let's say like I put it back to 0, 0 so you guys can see it again. What this does is with respect to wherever I move my camera position, my main camera will go there with respect to the original one. So what this means is that I can change from point of views simply by, so right now I'm in third person point of view, right? Say mid game, I don't know, I was in some action game and suddenly I want to change point of view to a first person. Instead of changing the camera, I changed the camera position and now I'm first person. If I want to be like a shorter point of view, I can like edit this in screen and you can see, oh, this is what I want to do, right? So say I like this for some reason, like a shorter game or like something, you know? Then what I'm going to do is I could just copy component, paste component values. And this is used in a variety of applications, camera pause. Two reasons. One, if you're a humanoid, you usually don't like putting a camera in a like in the person's limbs because if a character is being animated, they don't want to follow. Let's say I had something that was rotating and I had the camera attached to something that was rotating. You don't want your main camera to be childed to a rotating object. So what this does is it just takes the position from wherever your camera position is and it moves your camera to that position. Because your orientation shouldn't matter, right? And I added the camera object just by creating empty and calling it camera pause. And I parented the camera object just by dragging it into the component I want to parent, right? The biggest thing in most scripting languages like this one is making sure that you put your like you reference correctly. Like you need to make sure you reference your main camera. So when I go to main camera, I need to make sure that my reference for my position is my camera pause here, right? So what that does is if I go back to the code, I have this as my reference. I have public, right? That means I'm referencing a positioner. I take the game object and I get the position of the positioner and I make that into my position for the camera. What's the check in code? I forgot to put it at the start. What's the check? What check? What code? Print? Oh, check in code. Yeah, that. Okay, are we good? Any other questions? Okay, so now I just want to make sure all of you guys have downloaded the assets, right? If you haven't downloaded the assets, you should go download the assets first. I will send a link. I believe I have gone 15 minutes over time, but I believe that we should still be able to get some sort of Kahoot in, right? Let me get the link for you guys. Let me first get you the asset links. So make sure you guys download that because I'll be starting the second lesson after they finish the quizzes. And they will be doing it in Discord. So just stay up to date with the Discord. I will be ending this session now, and I believe we will be starting another one after this. So I look forward to seeing some of you guys back there. Again, if you have any questions, feel free to DM me on from the 7-week channel or anywhere, and I'll try to answer to the best of my abilities. If you guys liked it, I hope you enjoyed. And just a preview for the next time, we will be looking at animating a humanoid character. So we'll take everything I've done this time and try animating a human next. Okay. See you guys.